Facial expression recognition using adapted residual-based deep neural network is the title of our paper. The authors are Ibrahim and Professor Sueyu. So the plan of this presentation will be an introduction about facial expression recognition, methodology used in this paper, results and discussion, and the conclusion. So we know that the facial expression recognition is one field that is very interesting in the research area because it helps us with the human-machine interaction, threat detection. It can also be used in some car companies to try to monitor the drivers and so on and so forth. The emotions that are primarily classified are in the number of 7. You have the anger, disgust, fear, sad, happy, surprise, or neutral. So in this study, we will be trying to classify those 7 emotions. In FER, most of the used methodology in the early research was handcrafted feature extraction, and then they tried to classify those features using machine learning classifiers. So the mostly used image preprocessing techniques are violations that is an algorithm to try to find the face in an image, and also some histogram equalization, that is some image preprocessing technique. And the deep convolutional neural network made some massive progress in computer vision that can allow us to train deep models and have a good conversions, and those models can be tested in new data and perform well. So in the FER, the mostly used dataset are wild dataset and post dataset. The wild dataset are some images that are collected from internet, some as some videos of movies and documentary. The post dataset are those images that are been done in laboratories where they ask an individual to pose and they get the pictures. So some related works in this field are Hassani and Mahor. They utilized a novel network that they called ResNet LSTM to capture the spatiotemporal data. Mine et al. Also proposed the use of an attentional convolutional neural network instead of adding layers and neurons. Usar also developed a very interesting CNN by employing a hybrid feature strategy combined with HOG. And other authors focus on deep architecture with the attention mechanics using a residual masking network. So in this study, the methodology is using a convolutional neural network where it will be stacked some residual blocks. Those residual blocks will allow the backpropagation until the layers so that it will reduce the overfitting that can suffer a lot of deep neural networks. So the architecture is as follows. First of all, we have a convolutional block that is a stack of conv layer dropout, conv layer max pool, and dropout. And the conv layer is formed with 2 convolutional layers and 2 batch normalization layers. And in the residual block, we also have a conv and batch norm, and then the activation after the batch norm. In the other layers, the conv layers, we have the activation before the batch norm. And at the end, the previous output here will be added to the output of the residual block and then activated. So after that, we have a global average output layer and then the classifier. So the details of this architecture are: we have 3 convolutional blocks and 2 residual blocks, as I showed you before. We have a first convolution with 5 of 5 kernels where we will be allowed to try to capture a lot of features at the beginning, and the initializer used is the high normal. A rectified linear unit is used to have a nonlinear output. A batch normalization layer is used to try to centralize the gradient during the backpropagation, and we have a max pooling layer that will downsample the feature map. We have a dropout that will be able to drop some nodes so that we can avoid the overfitting at most, and the global average pooling at the end of the convolutional block for the flattening, and then at the end we have a number of parameters of 9 million that is much reduced compared to the original ResNet. So this slide try to explain the dataset that has been used in this work. It is a FERGIT, that is a combination of Markspace and FER 2013. This dataset is very famous in the FER research field. It has 49,300 images in the shape of 4848. So this dataset has some challenges such as imbalance, intraclass variance, and occlusion, as can show this picture, where you can see that the happy has more number of samples than other classes, and the disgust has very few number of samples. This image right here shows some samples of the dataset, such as angry, sad, and some other emotions. So some image pre-processing has been done on this dataset, that is to partition the dataset into 3 sets. We have the training set that has 90% of the dataset, 5% for validation, and 5% for testing. And then the data augmentation technique has been used to augment this data during the training. So the training phase, this is the environmental setup for the training. We trained our models in Google Colab Pro with a 24.5 GB RAM available. We did it into 2 phases. First of all, using a basic network without residual blocks, and then the proposed network. All the models were trained for 100. All the networks were trained for 100 epochs, and we used the data optimizer to train these models with those parameters. And then we used some callbacks functions to monitor the training. The results are discussed in this slide. We have the basic CNN results, and the metrics that has been used for the performance evaluation were the precision, the recall, the F1 score, and the accuracy. So at the end, we started first with 74% accuracy on the test set, and as you can see, the monitoring of the training accuracy and the training loss is giving quite good result without no overfitting. But after 100 epochs, we still didn't have much increase on the accuracy. So this is a confusion matrix that can show us how it is distributed between the true label and then the predicted label. The next result was the result of the proposed architecture. As you can see here, after 100 epochs, the training were quite high, over 90%, and the loss was dropping also very fast. This was due to the use of the cross entropy loss, but weighted one, because our dataset was suffering of imbalanced data, so we used the weight cross entropy to weight those classes that have few samples with high values. And at the end, we observed that there's a gap between the test accuracy and the training accuracy that is showing some kind of little bit overfitting, but not so high. And the accuracy is slightly better, with 75% better than the previous one. And to validate this network, the performance of the network, we try to train it also on CK Plus dataset that gave us a very best accuracy of 97%, although this dataset has a very few number of samples, and this monitoring was also quite good. So a comparison of state-of-the-art results were done on CK Plus with other models. We can see that this model using differential ResNet gave 95.74. Another improved VGG19 gave 96%, but our model gave 97% of the test set of CK+. And we tested also our model on some new images. As you can see, the process is first to crop the image and then use the model to detect the emotion, and the first one gave a neutral with 86% of confidentiality, but because of the misclassification of our model, some images were not good predicted, as this one that is predicting neutral, as you can see, this picture is a disgust picture. For conclusion, in this work we implemented a residual block architecture, and then we evaluate this model on FERGIT and CK+, and that gave us satisfying results. And the runtime was also quite fast due to the reduced number of trained parameters compared to other models. So that's all. Thank you.